So I'm going to walk us through an example of applying this reasonably quickly. I'm not going to show every single aspect of the tool, but I hope it'll give a really good feeling for how it works. We're going to apply it to a systematic review by Gravier and colleagues, looking at whether some prehabilitation, giving people or offering people some exercise training before they go through lung cancer surgery, improves their outcomes. The idea, of course, of being more physically fit, they would hopefully suffer less complications of surgery. And the systematic review included this meta-analysis. The primary outcome was post-operative complications. We can see from this that if we took it at face value, there's reasonably strong evidence that these exercise training interventions seem to be reducing the amount of post-operative complications, almost a halving of risk there. And we can see that's the old risk and bias profile there. So step one, applying the Rob-ME framework to this meta-analysis. So step one is defining the PICO and what sort of results would be eligible to go into this meta-analysis. In theory, if we had absolutely everything. So we'll spend a lot of time. The P is obviously people heading towards lung resection surgery. They were pretty broad, and any aerobically demanding types of exercise training compared with not doing that training, usual care, and obviously the outcome post-operative complications. It was a review of randomized trials, so all the designs eligible were randomized trials. They provided no particular definition allowing any type of post-operative complication, and there were no restrictions on how the outcome would be analyzed. So pretty broad. And so the first step, the second step is to look at the studies we have in the review and see whether there are any that may have measured our outcome of post-operative complications but not reported it. And if we run through them, we can see there all the 10 studies that were in the meta-analysis. They have ticks because we've obviously got data for those. And then we've got 4 more at the bottom that were in the review but not in the meta-analysis. So these are the ones we've got to think about in step 2. It turns out one of them had actually reported no adverse outcomes after surgery, the Benzo trial. So that could have been put in the meta-analysis with zeros and it would get 0 weight, but they didn't put it in. So there's clearly nothing to worry about because we know the numbers. They just don't contribute to the meta-analysis. Then we've got this Sommer trial, which actually was a 2x2 factorial trial where preoperative exercise was randomized as well as some post-operative exercise. And they presented the results for post-operative exercise, but they didn't present the results for preoperative exercise. So we put a question mark there because we just don't know why they didn't present those results. There's no particular reason to be concerned, although there's clearly there's no particular reason to be highly concerned, but there's clearly some level of concern. The 2 I'm going to focus on are the last 2. These are much more worrying. The first one, Stefanelli, did measure, it did not report post-operative complications as an outcome. But when we look at the study reports, we find that every result they did report had a p-value smaller than 0.05, which may be genuine, but it also raises some eyebrows. It's suspecting that possibly they did some other analyses that reached p-values bigger than 0.95 and didn't report them, including potentially post-operative complications. So we've got some level of concern about that one. And then the last one there, this was reported only in a conference abstract, but they do say in their protocol that they were measuring post-operative complications and don't report it in the abstract, whereas everything that is reported in the abstract, again, has a p-value smaller than 0.05. So that's it just does it make maybe more strongly suspicious that they're withholding that result because they didn't like it or it wasn't reaching statistical significance. So we've got 2 studies to be concerned about here. And here's an example of sort of forest plot that Matt was recommending earlier, where we see the results of the studies where we know the result, and we see what we do know about the studies where we don't know the result. and we can put the sample sizes on and the information that we do have, suspecting that the p-value is probably 0.05 for those two studies. I'm not going to say anything about step 3, which is about whole studies we don't know about. For now, I'll come on to that when we talk through the signaling questions. So let's get into the signaling questions, which is step 4. Those 8 questions that Matt was just talking about. So these are the 2 we start with. Are there studies missing or potentially missing from the analysis because of the p-value magnitude or direction of results? And then if they were they likely to impact on the summary effect estimate? Well, I'll just jump to the face. We've already seen that there are 2 studies missing that we believe may well be because of their findings. The question is whether those 2 studies would impact on the meta-analysis is not an easy one. There were not that many patients, 40 and 50 in the 2 trials, against a few hundred in the rest of them. Though our strong suspicion is that they had much less impressive results than the others, in that they probably have results near the null, possibly even favoring the control group. And the other important information here is that meta-analysis, I didn't mention it at the time, but it was a random effects meta-analysis. And in a random effects meta-analysis, if you add 1 or 2 studies that really differ from the other studies, then they can really pull the effect towards them. This wouldn't happen in a fixed effect meta-analysis, but it does happen in a random effects meta-analysis. So those 2 things combined, the fact that we think the studies probably had results much nearer the null, even beyond the null, and the fact that in a random effects analysis, such results could pull the result really towards the null, means that we think probably yes, if we had those results and we put them in the meta-analysis, it could really shift that summary estimate. So now we'll move on to considerations of whether there are whole studies missing. Do the circumstances generating these studies and the reports of these studies indicate there's potential for us to have completely missed studies? And again, if those studies had been found, would we probably have got results out of them? Well, we looked at the review. Well, I mean, the first thing we thought, this is an unregulated intervention. Exercise therapy, it's quite easy to do a trial of this. And we know that unregulated interventions are much less likely to be registered in clinical trials repositories. Furthermore, the review didn't even search clinical trial registries. So it seems to us perfectly plausible that there are studies out there that we wouldn't have found because they weren't registered and/or they weren't published. Though we think that those studies, probably some of them, if they exist, would have measured postoperative complications because, I mean, it's the primary outcome in review. It's likely to be the primary or a very important outcome of any trial of exercise before surgery. So we've got some strong suspicions in this domain as well. Then we can start looking at these more traditional methods, plots and statistical analyses. So does the pattern of results suggest that though any missing studies could be systematically different from the observed? Were there any sensitivity analyses? Well, let's look at the funnel plot for these studies. It's not beautifully symmetrical. In fact, it's a little bit of a worrying shape, I would say. We've not got a lot of studies, but what we do have is a little bit suspicious because we've got a line of studies down here which are really just skirting into the area of statistical significance, and the others we have are all pushing towards the area of a statistically significant benefit. And it looks as if there could well be rather a gap in the right hand side of the white triangle, which is an area of smaller-ish studies with null results, particularly null results. So this is highly compatible with there being some non-reporting of studies and certainly of results within studies. In fact, they didn't do any sensitivity analyses around publication bias, so we don't have any results to go on. And we're not suggesting that people go ahead and do new analyses in this area. So they're the issues that we cover in the signaling question. So we might try and reach an overall risk of biased judgment. To summarize what we found, there was evidence of likely or at least very highly potential non-reporting of results within studies, selective non-reporting. And those studies we thought could change the summary estimate. The circumstances we thought did indicate potential for the whole studies we don't know about with eligible results. And on top of that, there is some evidence of funnel plot asymmetry. This is well, let me not preempt the result. Dario, I think we've got time to do a little poll here. So the question is, given this set of responses essentially to the signaling questions, do we think that the risk of bias judgment is low risk of bias, giving some concerns, or high risk of bias? We've got more than half of people, 58%, thinking there's high risk of non-reporting bias here. About 40% think it gives rise to some concerns, and one person thinks there's low risk of bias. Okay, well, our judgment, and the one that we've built into the algorithm, which I know you haven't had time to digest, is we think these are really quite a concerning situation, and we think there's high risk of bias associated with non-reporting the results that should be in this meta-analysis but are not. And it's an interesting spread of results. So it'd be interesting to hear some questions about, or some comments even in the chat, about why people did not think that, and didn't quite agree with our judgment there, which is not to say you're wrong, but it's different from ours.